if we start with the bottom one, all right, triangle GHI is congruent to KJI. Okay. All right. All right. So that means this triangle 1 is congruent to that triangle 2. All right. And that means that is congruent to that. That is congruent to that. All right. And that, of course, is a what? Shared side. All right. This angle is congruent to that angle. All right. This is congruent to that. All right. And then this entire angle can be congruent to that entire angle. Okay. So we're trying to prove GHJ. My bad. I got to start all over. Used the wrong triangle. I apologize. So let's start again. Okay. So it says that GHI is congruent to KJI. Let's go with that. Everybody good with that idea? Okay. So then that angle is congruent to that angle. All right. This one is congruent to that one. And then, of course, the verticals are going to be congruent as well. All right. So now we're trying to prove the overlapping triangles are congruent. All right. So if I just want to go with sides, that's one side of GHJ, correct? And that's the other side, just so I got that side. Absolutely. Does HJ then serve as a shared side for those two? Yes, so that's going to be congruent. So now, how do I get the third side? Well, that's got 3, that's got 2, that's got 3, that's got 2. So we know they're going to be congruent to each other. All right? So basically, in a nutshell, I'm going to start with the given, which is triangle GHJ. GHI, and I want to make that mistake again, congruent to triangle KJI given. So I use GH was congruent to KJ. I used HJ was congruent to HJ. All right. So the GH congruent to KJ came from what 5 magic letters? CPCTC. The HJ congruent to HKJ comes from, of course, the shared side. All right. HI was congruent to JI, and GI was congruent to KI. Those two also came from CPCTC. So make sure when you do this that you include everything you deduct, and then we put those together. So as a result, HK was congruent to GJ. Adding congruent segments to congruent segments. Adding congruent segments results in congruent segments. All right. Which then gave us triangle GHJ is congruent to triangle KJH. Side. All right. This obviously could have come before that. The shared side could have come everywhere, but this would have had to follow when you put those two congruent. So this would have had to follow those. You do have other things at your disposal. Please don't forget, for example, once you have those congruent, is that an isosceles triangle? Yep. So we could have said those angles were congruent by the isosceles triangle property. Then we could have added that to get those angles congruent if we wanted to. The only difference is instead of side, it then would have been what? Side, angle, side. Now the top one, a little more challenging. All right, a little more challenging up top. The triangle EBF is congruent to triangle EBD. All right, so that's my shared side on that one. That's going to be congruent to that. That's going to be congruent to that. All right, everybody's good with that part of it. Now we're trying to prove ABF is congruent to CBD, the outside triangles. So AC is parallel to DF. As soon as you see parallel lines, ladies and gentlemen, you should think of what? Alternate interior angles. If those sides are congruent, it's an isosceles triangle, then these angles are also what? Congruent. Everybody good with that? And by the same reason those are congruent, that's going to be congruent by alternate interior angles. All right? Good thus far? Okay, so it says AF is parallel to DF, or perpendicular to DF. So that means this is a right angle there. And AF is parallel to DC, so they're congruent. They're parallel, sorry. Well, by same side interior angles, if that one's 90 and they're supplementary, this one also has to be what? 90. And if these are parallel, those also have to be what? 90. Do I have two angles and a side? I absolutely do. So the two outside triangles now congruent. Yep, but by angle, angle, side. So let's put it all together. Triangle EBF congruent to triangle EBD. Given. All right. Now you can list as many things as you want, or you can list what you use. That makes sense to everybody? So if you're writing it first and you just want to write everything down, hoping it all fits, go ahead. But the only thing we really used in our two triangles from that is that BF was congruent to BD by CPCTC. All right. And then from that, don't forget, we used that angle BFE was congruent to angle BDE. All right. Isosceles triangle property. All right. Then we went with the second given statement. AC is parallel to DF. That was given. And because AC was parallel to DF, we went with the angles. Angle ABF congruent to angle EFB. AIA. And we also went with angle CBD, congruent to angle EDB. Both by what? Alternate interior angle. All right. Combining those allowed us to say that angle ABF was congruent to angle CBD by our old friend, the transitive property. By our old friend, the transitive property. Okay. And then for the last component, we used AF as perpendicular to DF, and AF was parallel to DC. That is given. That allowed us to say each of the following. You got to realize you can't say it all at once because one comes from the other. The first thing we said is angle AFD is a right angle. Definition of perpendicular. That allowed us to say angle CDE was a right angle. Because of what? Same side, interior angle. And that in turn, combining those, allowed us to say that angle A and angle C are right angles. Same side interior. This would definitely be a fill-in, by the way. All right. And then that allows us to say that angle A is congruent to angle C. All right angles are congruent. And we combine all those, finally say triangle ABF congruent to triangle CBD. And that was angle side. Good? Okay, so what's due Sunday at midnight? Homework 4.7 practice. Okay? Now, the last part of next week's quiz on 4.4 CPC 4.5 isosceles triangle properties and 4.7 overlapping triangles deals with systems and quadratics with isosceles triangle properties. Okay, you guys next week go Tuesday, Thursday, right? So your quiz will be on Friday on 4.4, 4.5, and 4.7. 4.6 we'll do later in the year after we do Pythagorean theorem because it involves right triangles. Okay, so here's the idea. When we did isosceles triangle properties, we focused on the fact that if these two sides were congruent, then these two angles were congruent. That was the majority of your homework from that side, which is great. But there's one other thing you have to realize. If you have an isosceles triangle and that's perpendicular, two things occur. Number one, that angle is bisected each and every time. Number two, that has to be the midpoint of the base. So we said a little bit in notes, and now we're focusing on that. If you get one, you get the other two. All right, so what do you want to do first? You want to do linear or you want to do quadratic? Doesn't matter? Linear. Okay, so we divide our box in half. We'll do the linear first. The linear is over here because there's no square. So 12x plus 9 equals 3 halves x plus 51. That's a 3 halves, by the way. I apologize for the format. All right, everybody good with that idea? So you're just setting them equal to each other. Now, for those of you who are fraction folks and don't like fractions, my only denominator is 2, so I can multiply both sides by what right away? 2. That would give me 24x plus 18 equals 3x plus 102. Before moving on, everybody good with that idea? Okay, what's smaller, 24x or 3x? 3x. So chances are I subtract that from both sides to reduce the possibility of negative numbers. 21x plus 18 equals 102. How then am I going to get rid of the plus 18? Subtract 18. How am I going to get rid of the multiplication by 21? Divide. X equals 102 minus 18 is 84. 84 divided by 21 is a nice integer value. Okay, I can then plug that back in. 12 times 4 is 48. 48 plus 9 is 57. 3 halves times 4 is 6. 6 plus 51 is also 57, so I checked my work. All right, up here also says 25x. So 25 times 4 is an even 100, which means the other leg would also be what? 100, which allows me to get the triangles per perimeter. Okay? So you got 100, 100, 200. If it asks you, the perimeter would be 314. Now the quadratic part of it. Okay, that angle's bisected, so we set them equal to each other. W squared minus 4w equals 7w minus 24. W squared minus 4w equals 7w minus 24. Everybody good with that idea? All right, now we're going to get in standard form. W squared minus 11w plus 24 equals 0. All right. I'm then going to solve it. What two numbers go into 24 add up to 11? Good job, 8 and 3. So it's w minus 8, w minus 3. The opposite of negative 8 is 8. The opposite of negative 3 is 3. So those are my two algebraic solutions. Now I go over here, and if w is 3, 7 times 3 is 21. 21 minus 4 is negative 3. What's our issue with that? In terms of this class, we're not going to have negative angles. So 3 is what we call x trainee us. So our only actual solution is 8. If I plug that back in, 7 times 8 is 56. 56 minus 24 is 32. 8 squared is 64. 4 times 8 is 32. 64 minus 32 is 32. And if those are 32 and that's 90, can I get those angles as well? Yep. I'm just going to either add them up and subtract from 180 or just subtract 32 from 90. Either way you get at it, the angle is 58 each. All right. Everybody good? All right. The one on the bottom, we got P's and Q's. Okay. We got P's and Q's, which tells me we got a system. Okay. Number one, isosceles triangle. If the angles are congruent, so are the sides. Okay. So that would give me my first equation. which is 7q minus 1, equals 6p plus 13. All right, now if that's the angle bisector, it's the perpendicular bisector of the opposite side, which means 8p minus 12 equals 3q plus 1. 8p minus 12 equals 3q plus 1. Okay. Nothing really looks like it's going to become 1, so if you want to use substitution, that's fine, but because of that, I would prefer to use elimination, which means I got to get them in standard form. So, to get this one in standard form, 6p minus 7q equals negative 14. Everybody good with that? I just brought the 7q over there. I brought the 13 over there by subtracting. Do the same thing here. 8p minus 3q equals positive 13. Everybody good? All right. I'm just going to eliminate the q's because I want them to be opposites of each other. So I'm going to multiply the top one by 3 and the bottom one by negative 7. Everybody understands why the bottom one's negative? Because I want one to be positive and one by negative. That would give me 18p minus 21q equals negative 42. Negative 56p plus 21q equals negative 91. This becomes negative 38p equals negative 133. And divide by negative 38, and that comes out to be 3.5. All right. We'll go back over plugging it back in to get Q for those of you that like to do that. But if P's 3.5, can I plug that in right here? 3.5 times 8 is 28. 28 minus 12 is 16. If that one's 16, this one is also what? 16. 6 times 3.5 is 21. 21 plus 13 is 34. If that side is 34, this one is also 34. And again, I can get the perimeter. For those of you that would rather plug back in, I would go to any one of my original equations up here. So we plug 3.5 into that one. 7q minus 1 equals 21 plus 13. 7q equals 35 because the 21 plus 13 is 34. Add the 5. Divide by 7 and q is 5. And if we plug that in, we get the same value. Okay. All right. So the result of that. Hope I got it. Got it. Notes. Notes. Trade. Come on. Oh, there they are.